So similar to a lot of people today, I've got a really coarse voice, so we're going to see how this goes. So yeah, I said my name's James Stevenson. I'll give you a brief kind of outline of who I am and what I do before I begin. So I was a student at the University of South Wales, studied computer security, as well as before that I was an intern at Logic, kind of a cloud security company. These days I'm now a graduate in BT security. So what are we going to be talking about today? Well, this is a quote from IBM, and it's to do with predictive security, right? So preemptive security. So doing something now, spending some money now, spending some time now to help protect ourselves in the future. Today I'm going to be talking about offender profiling, which is a type of preemptive security. And offender profiling is all about creating a knowledge base on a malicious actor. I want to break today up into three main areas. I want to talk about what offender profiling is and why it's important. I want to talk about what already exists, so some white papers, some research papers that use offender profiling. And then I want to talk about how we can use offender profiling in other areas and how we can use offender profiling in security operations. So what is offender profiling, right? I keep talking about it, but what actually is it? So offender profiling is all about creating a knowledge base on a malicious actor. It's all about looking at the bigger picture of an attack so that we can better protect ourselves. A knowledge base, that's great, right? But what does knowledge base actually mean? Well, for this, we break that knowledge base into three main areas. We look at information relating to the target. So we say the who and the what. Who is the target and what was targeted? With an individual, a group, with a government organization. And we say, well, what actually was targeted? What asset was targeted? We also look at information on the attacker. Again, the who and the what. Who is the attacker? With an individual, a group, a government organization, with a state-sponsored. And what attack vector did they use? Finally, to build that knowledge base, we also have some general information. So when did this occur and why did this occur? And it's all of that information that comes together that builds this knowledge base, that builds this profile on these malicious actors. There's an example I like giving for offender profiling, and I'll be honest, I like giving it because it's simple, it's easy to get our heads around. It's the idea of a DOS attack. So let's say we're protecting a customer's network, and they're continually getting DOSed by a Scandinavian hacker group between the hours of, say, 6 and 8 each day. We can tell our customers, okay, put extra load balancers in place at these times, and then for the rest of the day, use what you usually have. So here you're using offender profiling, you're using preemptive security and some general security techniques to help protect your customers. So that's what offender profiling is, but why is it important? Why do we need it? Well, this is a quote from the Los Angeles police chief. It's actually to do with predictive policing, but I think it describes offender profiling quite well. It's the idea that we're not getting more money, we're not getting more staff. We have to use what we have now effectively. And that's the same in security. So security is not the buzzword it once was. It doesn't have the endless budgets it maybe once did. It's all about utilization, using what we have effectively. So if we can use preemptive security, if we can use offender profiling to spend some money now, some resources now, and possibly it will help protect ourselves in the future, then surely that's worth it. So that's why offender profiling is important, why is security important, right? We wouldn't be here today if we didn't believe security was important. Well, this is a statistic from Have I Been Pwned. If you don't know, Have I Been Pwned is kind of a massive online database of breached account credentials. You type your email address in, and it tells you if you've been part of a data breach. This is the amount of compromised accounts that were listed on Have I Been Pwned on the 12th of the 2nd, 2018. And that number is really interesting, right? Not only is that a massive number, but it also shows us that security isn't going anywhere. It shows us that security is in it for the long haul. Because as long as we have things that can be broken. As long as we have things that can be broken, we have things that need protecting. So that's why offender profiling is important, that's why security is important. But what already exists? What are some examples of white papers, of research papers that use offender profiling? Well, this is a white paper by Mandiant. It's probably the first white paper I ever read. It's to do with APT1. It's quite old these days, but it's definitely worth a read if you haven't. This white paper goes into the malicious actors, goes into their motives, goes into their attack patterns, and who they are and what they do. All in all, it builds that bigger picture on them. We've got another white paper here. This one is by F-Secure. This one is quite similar, but instead it looks at the Callisto group. Again, it looks at motives, it looks at attack patterns, and who they are and what they do. Again, building that bigger picture. Final white paper here. This one is by McAfee. This one's slightly different. Instead of looking at one specific malicious actor, this is McAfee's annual threat report. So it looks at a whole range of different malicious actors, different patterns, different motives, but again, builds that bigger picture. And you might be starting to see a pattern here, because offender profiling is all about looking at that bigger picture. It's all about understanding the bigger picture of an attack so that we can better protect ourselves. So that's an example of offender profiling in research, right? In white papers, in research papers. But where else can we use offender profiling? As I said earlier, I worked in a security operations center. I worked in a company called AlertLogic for around about a year. At a high level, this is how most security operations centers work. Again, at a high level. We have two main elements. We have our customer, and we have our SOC, our security operations center. Our customer will have an IDS, an intrusion detection system, a WAF, web application firewall, or some sort of logging system. They'll then send logs from themselves to our SOC. In our SOC, we'll have an analyst who will review those logs. We'll say, well, what's actually happening here? Is this a false positive? Is this a false negative? They'll then write up some feedback and send that back to the customer. And we get this really good feedback loop, right? We get logs, analysis, feedback. And generally, it works really well. Where it doesn't work that well, however, is generally we're only ever looking at one attack at a time. We might be looking at multiple events or multiple incidents, but generally we're only ever looking at one attack. So the question is then, could we implement offender profiling into security operations? Well, yes, we could. It's been done. One of the ways we do this, and one of the easiest ways of doing this, is just by latching on a framework for offender profiling to what already exists. So instead of starting afresh, we just append to what we're doing. So we take those logs as usual, we analyze them as usual, but then we also start bucketing that information. We say, well, this attack is related to an attack you had last week. This attack is related to an attack you had an hour ago, and this attack is related to another attack another one of our customers has had. And then when you send the analysis back to those customers as usual, you can also send this bucketed information, allowing them to compare attacks, allowing them to prioritize attacks, or to just simply understand what is happening to them. So for the rest of this talk, I'm going to talk about some methods we can use to do that, some high-level methods we can use to do that. To start with, though, you might be thinking, well, James, that's great. Surely it's time to dive in. Well, not quite. Before we do that, we have to look at what we're protecting. Because at the end of the day, we can't protect what we don't know. And one of the ways we do this is we create an asset profile or an information classification. As I said earlier, I own a website, jamesstevenson.me. That's an asset. That's something I'm protecting. That's its name. Well, its classification. Is it high risk? Is it low risk? A description. Well, it's a WordPress website running an email server backend. Owner, custodian, that's myself. Finally, the user, that's the public, that's you and I. And the reason we build these asset profiles is, again, so we can better protect our assets. For example, let's say we have two assets, a high-risk asset and a low-risk asset. If we had to, well, let's say they're being attacked, right? Let's say a malicious actor is targeting those assets. If we had to prioritize one of those attacks, which one would we prioritize? Well, it would probably be the high-risk asset, right? Because that one is intrinsically of a higher risk. And we'll see how this comes into play later on, but for now we just need to know that to better protect our assets, we need to know what they actually are. So moving on to our first method. Yeah, sure, I can do that. So looking at our first method for offender profiling. This method looks at attack significance plotting. It says, can we look at a time frame of our malicious actors? And the way we do this is we set this time frame. So we've got the time between 4 and 5 on a specific date. And whenever we see an attack from a specific malicious actor to a specific asset, we increment its significance, we increase it. And if we don't see an attack from a specific malicious actor to a specific asset during that time frame, we decrease the significance, we half-life it. There's some maths behind it, but really we just need to know that we increase or we decrease. And that's really useful, because that then allows us to compare malicious actors. So here we can see two different malicious actors, two different attacks. We can see one from China and one from Russia. One in China kind of going towards the top, a lighter blue. The one from Russia staying towards the bottom, kind of a darker blue. We'll go into these naming conventions later on, but for now that's just what we need to know. We can see that this Chinese malicious actor continues to attack the asset throughout this time frame, while the Russian malicious actor attacks, stops, and continues. So if this was the only information we had from these attacks, which of these attacks would we prioritize? Well, it would probably be the Chinese malicious actor, right? Because that attack is far more frequent, it's far more pressing to us or our customers. Now, this method does make a massive assumption. It assumes that attack frequency is directly related to attack significance, which just isn't the case. But for this, it's a good baseline. So moving on to our second method for offender profiling. This method looks at risk. It says, what is the risk of this attack to us or our customers? The way we do this is very similar to the OWASP risk rating methodology, if you know it, and we take two areas. We take likelihood and we take impact. And we answer several questions in those areas, again, scoring them between 0 and 10. Now that scoring can be qualitative or it can be quantitative, but generally it's going to be the same framework used across all of our attacks. So here we've got questions like, well, what was the complexity of the attack? What was the ease of discovery, ease of exploit? And again, they're all rated between 0 and 10. We do the same then for impact. We say, well, what was the loss of confidentiality? What was the loss of availability? What was the loss of integrity? And again, we score them between 0 and 10. And you might be thinking, well, James, these numbers are awfully low. And that's because they are. So this attack was against a honeypot, so it was designed to have a low impact. We then take an average of both of these scores. So we take an average likelihood and an average impact, times them together to get an overall risk score. That risk score can be a number anywhere between 0 and 100. Generally, the higher the score, the higher the risk. So again, if we had two attacks, two malicious actors, one with a risk of 70 and one with a risk of 30, we'd prioritize the risk of 70, right? Because that one is intrinsically a higher risk. Moving on to our next method for offender profiling. So here I really didn't want to talk about the Subkill Chain. Some people love the Subkill Chain and some people hate the Subkill Chain. There was a talk on this yesterday, but if you don't know, the Subkill Chain is a method by Lockheed Martin for analyzing the life cycle of malware exploitation. Generally, it works really well in what it tries to do. Here we're going to be looking at a far more generic kill chain model for computer security. Right? So this model looks at researching targets, it looks at testing, actively attacking, all kind of actions which is doing the thing. And you might think, well, James, that's great and all, but what does this have to do with offender profiling? And the reason we do this is so we can pin these categories to our malicious actors. We can say, well, at this time and date, malicious actor A was in the research stage, while at the same time and date, malicious actor B was in the reconnaissance stage, or maybe the actions stage. So if that's the only information we had, we'd prioritize the malicious actor in the actions stage, because that one is further along in their attack. And we'll see how this comes into play later on, but again. So moving on to our fourth method for offender profiling. This method can be the simplest, or it can be the most complex, because it's all to do with asking questions about the attack, kind of really qualitative questions. Questions like, well, who was the target? Were they an individual, a group? Were they a government organization? We ask questions on, well, why were they the target? Were they the only target? Was this part of a massive reconnaissance attack? Was this part of a singular spear phishing attack? And then, similar to that question, why were they the target? If company A was targeted, why was company B not targeted? We then also ask questions on the attacker, again, if we know the answers. So who was the attacker? Were they an individual, a group? Were they state-sponsored? Questions like, well, what was their motive? Again, if we know. Was it financial? Was it malicious? Was it hacktivism? And then finally, coming off that point again, did anything happen leading up to the events of this attack? Was there anything on social media? Was there anything on the news? Were there any laws, legislation passed? Or did we or our customers receive any threats? And it's all of that information that comes together that allows us to answer this final question. And that's with the information we have now, with the information we have on our target and our malicious actor, is this attack likely to continue? Because building a knowledge base is great, looking at the bigger picture is great, but understanding if we are still at risk is far more important. So moving on to the final method for offender profiling. This is method 5, when really it could be called method 0.5. Because instead of looking at offender profiling, it looks at offender categorizing. It says, can we create a subunique naming convention for these malicious actors that we can instantly glean information from? The way it does that is it breaks these naming conventions into 4 main areas. It says, what is the location the malicious actor was first seen, or is most commonly seen? What is the date the malicious actor was first seen? The risk score, which we derived earlier on, and then the last octet of the first seen or most common IP address. And that just gives it its kind of subunique identifier. And here we could use IP addresses, we could use hashes, we could use MAC addresses to identify these malicious actors. This is just one example of something else we could use. So there we have it. That's kind of been a very high-level glance at offender profiling. We've looked at what offender profiling is and why it's important. We've looked at how we can use offender profiling in research and white papers, and we've also looked at how we can use offender profiling in security operations. Now, the real takeaway of this talk, though, comes in around the next 30 seconds, and it's inspired by this quote. And it's the idea that intrusion analysis, security analysis, network analysis, they're far more than the tools we use. They're all about understanding something. In some of those cases, it might be about understanding attacks, and offender profiling shows us that every attack is orchestrated, right? Every attack has a purpose and a motive. And in better understanding that purpose and motive, we can better protect ourselves. So, thank you all for your time. Thank you to the organizers as well. If you've got any questions, feel free to ask me now, come find me afterwards. Whereas I'm also on Twitter at _James Stevenson, and I'm super open for feedback as well. So this is the only second time I've done this talk, so if you've got any feedback, feel free to find me afterwards. We can have a chat. Thank you all.